How we can store electricity and save the world. We take it for granted that electricity will flow to our light bulbs, computers and microwaves at exactly the moment we need it. We owe that reliability to the electric grid, a vast and complicated machine that constantly adjusts to balance the supply of electricity coming in from power plants, wind turbines and solar panels with the demand from customers. The effect that fossil fuels are having on the climate emergency is driving an international push to use low-carbon sources of energy. At the moment, the best options for producing low-carbon energy on a large scale are wind and solar power. But despite improvements over the last few years, to both their performance and cost, a significant problem remains: the wind doesn't always blow, and the sun doesn't always shine. A power grid that relies on these fluctuating sources struggles to constantly match supply and demand, and so renewable energy sometimes goes to waste because it's not produced when needed. The race is on to find new and better ways to stash power. Scientists and entrepreneurs are already testing new technologies and improving old ones to expand capacity and bring down costs. One of the main solutions to the problem is large-scale electricity storage technologies. These work by accumulating electricity when supply exceeds demand, then releasing it when the opposite happens. However, one issue with this method is that it involves enormous quantities of electricity. One of the biggest obstacles is the efficiency, meaning how much electricity is returned during discharge, compared to how much was put in during charge. Lithium-ion batteries is the most efficient way to store energy, with an efficiency about 80 to 90%. But with this option being way too expensive, the efficiency for the alternatives is about 50 to 70%. Most pumped thermal electricity storage systems aim for 50 to 70% efficiency, compared to 80 to 90% for lithium-ion batteries, or 70 to 85% for pumped hydro storage. But what arguably matters most is cost. The lower it is, the faster society can move towards a low-carbon future. As it stands, several organizations already have working, real-world prototypes with hundreds of different ways to store energy. Some countries test to fill water up in the mountains and store it. When it is needed, they release the water, and the water falls down the mountain and starts some turbines, which generate energy. Other places, some test to use stones as batteries. The stones are stored in the ground and are heated up. When there is a lack of energy, cold air is pushed into the hot stones, and it generates steam, which starts turbines, which generate energy. The advantage of these two methods is that the water and mountains never get old, as well as the stones never tires out. There are many other ways to store energy, and every day we are one step closer to find an eco-friendly way to store energy and save the world. It could be 5 years, or it could be 20 years, before we are ready to implement carbon-free energy storage. But one thing is sure: the time will come, and hopefully it will not be too late.